Hi everyone, so let's look at these reactions in more detail. So reaction of calcium with water. Calcium is a moderately reactive metal and calcium is a dense metal, so means that it will sink here. That's why it's at the bottom. We have an inverted funnel which is going to be able to allow the hydrogen gas produced to be oriented into the test tube or the boiling tube, and hydrogen gas is going to be collected over water. Hydrogen is insoluble in water. This is why we can collect it over water. If a gas is soluble in water, you cannot collect it over water because all of it is going to dissolve in the water itself. Right. So hydrogen gas, this can be tested by using a lighted splint and you're going to get a pop sound. Then you have the reaction of moderately reactive metals with steam. So this involves reaction of magnesium or zinc with steam. So you're going to have the metal sample over here either as a powder or as a ribbon. You can have the magnesium ribbon over here or you can have the magnesium powder over here. Then here you're going to have a piece of glass wool which is going to be soaked in water. And here we have the water so that when you heat it with the Bunsen burner, it's going to cause the water to turn into steam. So you'll have water, so liquid state into gaseous state. And the gaseous water, so H2O gaseous state, this is going to react with the magnesium powder, and when we do the reaction, sometimes we're going to go back and forth with the Bunsen burner to heat the magnesium a bit, to heat the glass wool a bit, right, to maintain high temperature in the area so that the reaction goes faster. And we need the action of heat to speed up the reaction, to speed up the rate of the reaction, because magnesium and zinc are moderately reactive metals. When this burns, you're going to have, so for example, if you have magnesium, it's going to burn with gaseous H2O. This is going to produce magnesium oxide, so you are going to see a white ash of magnesium oxide here. So this is going to turn white over here, and then you're going to have bubbles of gas which is going to be collected over here through this delivery tube, and then you have hydrogen gas, and then you can test the hydrogen gas using lighted splint. So you have magnesium oxide plus hydrogen gas which is produced. So this is solid and solid. Next, we're going to see the reactivity of metals with dilute hydrochloric acid. Hopefully, you've been able to write the chemical equations. I'm going to write them down. You can check your answers. When you're writing equation, make sure that you have the correct valency. So, potassium valency 1, chlorine valency 1, sodium valency 1, chlorine valency 1, calcium, magnesium, zinc has valency 2. So calcium valency 2, Cl valency 1, so CaCl2. For iron, we're going to take iron-free chloride, which is formed. So iron and chlorine, iron valency 3, chlorine valency 1, so FeCl3. And then to balance, we're going to use these numbers. Okay, so verify your equations. Now, when you look at the reactivity series, the vigorosity of the reaction is going to decrease down the reactivity series. Potassium, sodium, they react pretty violently. Calcium and magnesium, they react fast. But starting from zinc downwards, the reaction starts to get slow. And for aluminium, actually, if you look at the reactivity series, aluminium is here. below magnesium. But when we do the reactivity of aluminium with acid, we actually found that aluminium is less reactive than zinc or iron. So it reacts very, very slowly. So why does that happen? This is because aluminium, when it is exposed to oxygen, it's going to react with that oxygen in air. So oxygen in air is going to cause an oxidation reaction. Oxidation means it's going to gain oxygen. So aluminium is going to gain that oxygen and form a compound. So you have aluminium that reacts with the oxygen to form a compound which is aluminium oxide. Now, aluminium oxide, Al has valency 3, oxygen has valency 2. Therefore, aluminium oxide is Al2O3. So this is aluminium oxide. So this is a solid, and this solid is going to lay on the layer, is going to stay as a layer on the aluminium. So the real aluminium, the clean aluminium, the pure aluminium is going to stay inside if we have the ribbon. So it's going to stay within the ribbon, and the ribbon is going to be coated with a layer of aluminium oxide. So this layer of aluminium oxide is going to act as a protective layer and is going to prevent any form of reaction from happening. So aluminium is above iron and zinc but reacts more slowly. Suggests why? Aluminium is reactive. It reacts with oxygen in air to form aluminium oxide. The aluminium oxide acts as a protective layer that prevents any reaction from happening, or which makes the reaction very slow. So suggest why reaction reacts more slowly compared to iron and zinc. This is because aluminium will react with oxygen in air and form a layer of aluminium oxide, which is going to act as a protective surface that prevents reaction from happening fast. Right? So balanced chemical equation, we have the equation here. We have to balance this. So I'll put 3 here, so 2 here, so 3 here, and then 4 here. So we have our equation which is balanced. What type of bonding is in aluminium oxide? So Al2O3, we have aluminium, which is a metal. We have oxygen, which is a non-metal. Metal and non-metal, we have ionic bonding. So metal will form cation, non-metal will form anion. So you have ions in there, so you have ionic bonding.